Okay, let's get started. Hi, everyone. I'm Anil Kumar, Director of Product Management at Couchbase. Along with me is Mike Wiederhold. He's the Engineering Manager at Couchbase. So, so we are very excited to talk about, we recently announced our Couchbase Autonomous Operator 1.0 GA. And in this today's session, we're going to talk about how you can achieve Couchbase as a service in your own deployment, right? So the whole talk is about the autonomous operator and what it can enable for you. So I want to get right into the topic of Couchbase as a service. So the way I want to talk about is like, let me talk about the problems or the challenges we want to handle, right? What are the challenges we are trying to solve here? And this is what we heard from many of our customers. So when we talk to our customers about like what challenges they have, is it a hybrid cloud, multi-cloud strategy? We are moving to the microservice architecture, and that's what we kept hearing from a lot of customers. I'm going to take one example from last year, right? This is one example, by the way. So this customer, so this is Naveen Eppa from DreamWorks Animation. He did a presentation last year at Couchbase Connect Silicon Valley. It was apparently here in the same venue. So in his talk, he talked about the problems they had faced, right? The problems he listed out is manual deployments. Is it coming correctly? I think there's a screen. Okay, so the problems he talked about is the manual deployments because they're, ooh. It's, all right, I'll just ignore and start talking. So yeah, so manual deployment of their entire application stack. So that includes their database as well as applications. Dedicated hardware for databases as well as for the application. Single point of failure because in the past they had monolithic architecture for their application as well as their database, right? So it's like single point of failure. Inconsistencies between the environments because there's chances of the patch might have been missed from test dev to pre-production, right? So there's a inconsistency between the environments. Cron jobs are like, you're running the cron jobs on the same data nodes and the same database nodes. And if you lose the nodes, you'll lose the job also, though. So you'll lose the functionality along with that cron job. Scaling was tough because in the traditional databases, you only scale up, right? So there was a challenge. Static infrastructure, it was very tedious process to move from one infrastructure to another infrastructure. Let's say if you want to move from private cloud to public cloud, or you want to move from even the bare metal to the VMs, moving from one infrastructure to another infrastructure was very, very tedious process because there was no industry standardization before. Right? So this was the problems he kind of talked about. Okay, these are the problems he talked about in the past. And then he talked about the solution they built, right? On top of, this is all they built themselves in the DreamWorks. Okay, I don't know what's happening. Okay. So, and then he talked about the solution they built, right? And the solution they built was treating the database as a cloud-native application, right? And the things they did was containerization, adopting Kubernetes, and moving to microservice architecture, right? And what that provided them was automated deployments.
Maybe it's an issue with the dongle.
Okay.
Looks like it's an issue with the dongle, or you can't use, you don't have a dongle in there.
Okay. Okay, all right. So moving to the cloud database to the cloud native application by containerization, by adopting Kubernetes, and by adopting the microservice architecture, they were able to get automated deployments, efficient resource usage and tracking, multi-tenancy, ease of management, monitoring, alerting, automated backups and restores, elasticity, right? And that's precisely what we have done with the Couchbase Autonomous Operator, right? So whatever problems and the challenges the DreamWorks faced and the solution they built themselves is what precisely we have solved for you guys. So the Couchbase Autonomous Operator, right? We announced Couchbase Autonomous Operator 3 weeks back. It's GA now. It's 1.0 GA now. So the whole idea of the goal of the Couchbase Autonomous Operator is to take away the operational complexity of managing Couchbase server by you. So what we have done is we have built a native integration with Kubernetes. We have built a custom Couchbase specific controller which extends Kubernetes API, right? So we can put our domain knowledge of Couchbase, how to run Couchbase, how to configure it correctly, how to scale it, how to in case of the node failure, how to recover back. All of that domain knowledge of Couchbase is what we have put in the Couchbase Autonomous Operator. Right? Here's the architecture of Couchbase operator. Right? And we will go into the details when the Mike does a demo. He'll talk about each of those components. There are two entities here, right? So there is Couchbase Autonomous Operator, which is what we have shipped, right? It can manage one or many Couchbase deployments in the same namespace. Right? So if you want to have Couchbase clusters, like one to many Couchbase clusters, all of that can be managed with one Couchbase Autonomous Operator. At a high level, there are three controls. We have services, pods, and volumes. And then, as I said, we'll talk more about those in the demo. So the way it flows, and if I show you the next slide, it will be much clearer. So let's say a SRE or a DevOps engineer, the first thing he would do is he'll deploy the Couchbase Autonomous Operator. So once the Couchbase Autonomous Operator is running on the Kubernetes, now you can you define a configuration file, right? So this configuration file is for your Couchbase cluster. You define what's your Couchbase cluster settings are, how many buckets you want to create, and if you don't want to create the bucket, there is an option to disable the bucket management. You define if you want to use MDS, like if you want to have 3 data nodes, 2 index nodes, 2 query nodes. Now that we are going to announce analytics, we can even have analytics nodes. You define all of your topology in the configuration file. Even you define your resources you want to allocate for the pods, the persistent volume you want to attach to the pods, all of that goes into this configuration file. Once you have this configuration file, as a DevOps, you push this configuration file to the Kubernetes, it gets registered, and that's when the operator picks it up and starts its job. It will start deploying the Couchbase cluster, configuring them, gets the whole deployment up. It's a fully automated deployment, right? So the state you wanted, right? So you have a state which you defined in the configuration file, like in your blueprint, and that's the desired state which the operator is going to maintain on the Kubernetes cluster. Any questions before I go further? And again, there are a lot of things we will show it in action in the demo, but if you have any questions, I can take it now. Okay. So at a high level, these are the awesome features we have shipped in the 1.0. There is auto provisioning, and by the way, this is all the things we'll show it in the demo today. So auto provisioning, once you have the configuration file, the deployment, the whole provisioning of the Couchbase cluster is fully automated. There are 2 scenarios. We have auto recovery in case of node failure, like in case of one particular instance of Couchbase goes down. There are 2 things there are 2 scenarios. If you use persistent storage, we use the persistent storage to recover your pod, data as well as your pod. If you don't use persistent storage, we do the rebalance operation to bring the node back to the capacity. So that's fully automated again. We support cross data center replication. We support persistent storage, and this whole idea of let's say if you have a configuration file, and I was talking to some customers earlier about when they move from one environment to another environment, right? They want to have the change control or CI/CD kind of thing. So they want to have the configuration in one centralized place, so that so when they move from one environment to another environment, there is no chance of misconfiguration, right? So they have the exact same configuration in your test environment, in your dev environment, and in production and pre-production. Right? So that is through the that configuration blueprint you define. And we have also shipped supportability tools. So it's enterprise grade, it's production ready. So we want to make sure that if you have issues, if you have to troubleshoot, we have the tools to support you guys. Right. Moving to the next slide, one of the questions Mike and me, we constantly get this is, Kubernetes has the stateful sets. Why didn't we use the stateful sets? Why did you guys go with the operator? The main reason is, in fact, I usually tell this thing is like last year in the May in Red Hat Summit, I did a talk on Couchbase running on OpenShift using the stateful sets. We had to pivot away from the stateful sets because when we found out the stateful sets, yes, it's a custom made for storing these stateful application, running a stateful application on the Kubernetes. But then they are not really good fit for database. They are good fit for, in case of stateful set, what happens is the pods which are running within the stateful sets, they doesn't have any knowledge about the other pods, right? If you want to create a cluster, it's not possible with the stateful sets. And that's, so for one example is file server. If you want to run a file server, you don't need a custom logic in that case. So you want to make sure that the file server is running. It's, if there is a restart for the pod, it goes back, I mean, it comes back. So the file server is a good example for that use case. Whereas for running a database, you want to make sure that you have a domain information, such as one example I usually take is, so let's say if you're running Couchbase and one of your node fails. So we have in our database, what we have is like let's say the node is out for 1 hour or 2 hours. When you bring the node back, you want to see the time frame it was out. And let's say if there is a lot of data which is already in the persistent storage, you want to reconsider the data, right? So we perform this delta node recovery operation, which will synchronize the data, the time frame where the node was out. And then we do a warm-up operation and bring the node back. All of this custom logic or the domain-specific knowledge is what is missing in the stateful sets. And that's why we picked the operator model, where we can extend the Kubernetes API to put our custom information and create the operator, right? So OK. I think I talked about all these features. So now I want to invite Mike onto the stage. So we will go through all the features we have shipped in the 1.0. He's going to be doing the demo of those. Mike, cool. All right, thanks.
OK, so before we jump into the demo, one of the things that I want to talk about a little bit is just why operators fit so nicely into Kubernetes. And the easiest way to do that is if you look at Kubernetes from a high level, Kubernetes is basically just a configuration store and a bunch of controllers. And so if you look at an example in terms of how that's so powerful, if you take a deployment, basically when you want to create one, you fill out some YAML file, you take that YAML file, you push it into Kubernetes, and it goes into the configuration store. What some people might not know is that when Kubernetes comes back to you and says, OK, your deployment's been created, nothing has actually happened yet. And that's really where controllers come in. So for every different piece of configuration object in Kubernetes, and there's a piece of configuration for literally everything, there's a controller that listens for those specific pieces of information. And so in the case of a deployment, there's a deployment controller. And the deployment will wait until there's new creates, updates, deletes of that kind of configuration. It'll get passed to the controller, and then the controller will take the configuration that it's been given, look in the Kubernetes cluster, see if a deployment of that type exists. If not, it'll build it, or then that's deploying 2 nodes, 3 nodes, whatever it is, in order to get the deployment created, right, and to get your application out. And so what's really cool about operators is they're literally that exact same model. So they fit very nicely into Kubernetes. And the only minor difference when you create an operator is, so for us, we created a Couchbase cluster type. Kubernetes doesn't know about that by default. And so what we have to do when we create an operator is we first need to tell Kubernetes, hey, here's a new type that we want you to care about in your database. Sorry, just one second. OK. And so to do that, we create what's called a custom resource definition. And let me see if I can make this a little bit bigger. OK. So there's a lot in here, but most of it is just for validation to make sure that the configuration we push to Kubernetes isn't malformed. The important thing, though, is that you can see we've declared a new kind, which is a Couchbase cluster type. And then you'll also see that we have these short names. And the short names just allow us to do a little bit less typing on the command line. And you'll see them come into play later. But if you want to define just a new type for Kubernetes to manage, it's as easy as just filling out one of these short files. It could be as small as 12 or 13 lines, and then pushing that into your Kubernetes cluster. OK, so once we do this, Kubernetes now knows about our Couchbase cluster objects. And so, for example, if I run kubectl get cbc, it should have. OK, well, anyways, so we have the CRD registered. OK, so now Kubernetes knows about our new type. And the next thing is we need a controller, because there's not going to be anything by default that cares about Couchbase cluster objects. And so this is really the big piece of building an operator. And so when you build this, we ship it as a Docker image so that you can easily run it in Kubernetes. And all it does is it connects to the Kubernetes etcd database, and it says, I'm interested in knowing about changes to Couchbase cluster objects. And so with that, we can receive these types of configurations, and then we can actually go out and do anything in a completely custom way to actually build the cluster, from creating pods to creating persistent volumes, setting up services, making sure that the configuration of your cluster is what matches what your desired configuration is, and making sure everything is clustered together and healthy. And so at a high level, that's, to me, why operators are just kind of really perfect, a perfect way of building extensions into Kubernetes. And so with that, let me just create the operator, and then I'll show you the YAML file. Okay.
People in the back, can you see the text? I think we need to make it bigger. I think. Thanks.
Can you move the
There we go. Okay. So let me do this. Okay. And so just to give a quick example of what the operator file looks like. We deploy our operator into deployment. The reason that we do this is because this is the controller that's going to manage all of our Couchbase clusters. And if it crashes, we want to make sure that it gets restarted, and deployments are great at this. For the most part, anybody using our operator, you're never going to modify this file. The one key thing is just that the image type in this case is 1.0, because that's the version of the operator that you want to run. And so now let's create our first Couchbase cluster. So to do this, we simply fill out configuration just like you would. Sorry, this is the wrong one. You fill out a configuration just like you would for any other object that you're going to put into Kubernetes. And so some of the key things here is the name of the cluster is going to be CB example. We're going to run Couchbase Server 5.5.1. We've set some quotas for the data and index service. We have the default bucket, or we have a default bucket that we want to be created in this cluster. And I forgot to reset this from when I was testing it. But we're going to create a 3-node cluster, and each node is going to run the data query and index services. We also want to have persistent volumes attached to all the nodes in our cluster so that we can recover data during failures. And so you can see we have a volume claim template, which looks similar to how you would define this in a stateful set. And this will allow us to do dynamic provisioning. And then we're going to mount the volumes that get created to our default mount point, which corresponds to opt Couchbase at Couchbase, which is where we keep all of the data and server configuration. So creating a cluster is as simple as just running kubectl create-f and couchbase cluster.yaml. So before I run this, though, one thing I want to point out is that we actually ship our own specific tool for loading these clusters in. There's nothing to stop you from using kubectl, but we ship some extra validation checks in our tool to make sure that you don't actually make mistakes. And since a lot of this operator stuff is relatively new, the validation in Kubernetes is something that's still coming along. So this is kind of our temporary workaround until we get the official features in Kubernetes. But so to do that, you just run bin cbops-ctl, and all the other text on the command is exactly the same. So we do that, and now our cluster is created. And I'm going to come into the Kubernetes dashboard. You know what? They don't actually need to see that part. Okay, so the key thing here is, so you can see already we have our first pod in the cluster coming up. And as soon as this comes up, I'm going to SSH into, or I'm going to open a port so that we can see it. And it should just take a few seconds here. Sometimes it can take a little bit longer than others. Okay, so the first one's come up. So I'm going to open a port just so that we can see the Couchbase admin console here. I'm just doing this with the port forward command, which is pretty standard. And then I will log in. OK, and so you can see our first node has already come in. It's been initialized. And the second pod, which has already been created, it's been added into the cluster. And so all we have to wait for now is for the third pod to come in. And then the operator will rebalance the cluster. So we try to put as many create as many new pods and add them in before a rebalance, just so that we don't have to run the rebalance multiple times. So I'll give this a second to complete here, and you can see the cluster coming up already. OK, and so we got the third node coming in. And we should see a rebalance shortly. OK, so nodes are clustered together. And then if I come over to the buckets section, we should see the default bucket get created any second now. And there it is. And then if I come and I look at the settings on it, you can see it's 128 megabytes, which was set in the configuration file. So using the operator, if you want to deploy a cluster, it's as simple as you can just pass these around between people, or just writing up exactly what it is that you want your cluster to look like when it comes up in Kubernetes. OK, so aside from that, one of the other nice things that we make easy to do is scaling. And so whether you want to scale your cluster up or down, it's, again, as simple as making a small configuration change. So in this case, again, I got the wrong file. In this case, if we want to scale down one node from 3 to 2, we just change this parameter here, save the configuration, and then re-upload the configuration file. And if I come back to the admin console here, we should see very soon that the node 0002 here will be removed from the cluster and rebalanced out. And so we can see the rebalance kicking off. So this is going to take a minute or so. So I want to show one other thing, which is that Kubernetes also allows us to provide some extra status information to users while they're running their clusters. So if you've ever run kubectl on a pod, kubectl describe on a pod, and you get back a bunch of information, you can do the same thing on a Couchbase cluster. So you can run. So if we run the describe command on CB example, you'll see a bunch of information coming back. And so the standard stuff is just the spec, which is the configuration that you've loaded up. But when we get down into the status section, you get some unique things that are specific to a Couchbase cluster. So one is we only record the buckets that actually exist in the cluster in this section. And we also have conditions. So available tells you whether or not all your data is available and accessible. So this is obviously true right now because there's no failures. But if we have a node that's down, this will be set to false. Balanced in this case is whether or not the data is balanced properly across your cluster. We're in the middle of a rebalance, so this isn't the case, and that's why this is returning false. But when I run this again after the rebalance, you'll see it comes back to true. And then we also have a scaling condition, which says that the cluster is scaling from size 3 down to size 2, and it's scaling down. Aside from that, just printing out the pods that are part of the cluster. And then we have a list of events that have taken place in the cluster. And so it's pretty much exactly my play-by-play of what was happening when we did the initialization. Node 0 comes in, node 1, node 2, we do a rebalance, we add the default bucket. And then you can see since we've started a rebalance, but it hasn't quite finished yet, because we're waiting for the node to be removed. OK, so I can see that it's gone now. And so I'll just run this again really quickly. And you'll see we get the updated event for 0002 getting removed and that the rebalance is completed. You'll also notice that the balanced condition is set to true. And so the cluster is in a healthy state. So another thing that a lot of people want to do with Couchbase. So in this example, I created a cluster that had all the same services. But you may find out that your queries are getting overloaded and you need more query processing power. You don't need another data and another index node. And so if you want to do that, all that you have to do is copy one of the sections in the server's map. And so if I want to add one server, I just create a definition for a type of server that only has the query service and say that I want one of them. So I'm going to again push this back into Kubernetes. It looks like I made a mistake. Oh, right. Yeah. So this name, it doesn't really make much of a difference to users when they're using it, but it matters internally for the operator. So it just has to be unique. So I'll just call this query only. So try this again. OK, and then the configuration has been updated. And so we will again scale up here, and we'll wait for the query node to get added in. This time the rebalance will be quick because there's no data movement that needs to take place. All right, let's just check and see if, what's going on over here in the Kubernetes dashboard. So it looks like the pod is still coming up. Okay, and it's up. One other thing that I'll add is I'm running all of this off my laptop. So if things seem a little bit slow sometimes, it may just be for that reason. But we can see that the query-only node has been added into the cluster, and we're just waiting for the rebalance to kick off here, which should be very quick. OK. And so now we have a multidimensionally scaled cluster. So scaling is really easy with the operator. One of the other really nice things is the failure recovery. So if you have if you're in charge of managing a cluster and something crashes in the middle of the night, you might have to get up and fix it. With the operator will go about fixing situations for you. So we have this last node that we added in. So we can just say, well, what happens if we kill it? So kubectl delete pod cb example 03. All right, so this pod is now down. And so what we do here is we always wait for Couchbase's auto failover mechanism to kick in, just to make sure that it is OK for us to fail over the node. When the node does fail over, what it will do is it will activate the replicas on the other nodes, and so all your data will be available. Whereas right now, you're missing a third of, well, if there was data on this node, you'd be missing a third of your data. So once that happens, the operator now has to try to get this node back into the cluster. And since we're using persistent volumes, the operator will take the persistent volumes from the old node or the old pod. It'll create a brand new pod, attach those persistent volumes to that pod, and then attempt to delta recovery that node back into the cluster. And so this basically allows it to just pick up from where it left off. And so what you can see right now is the operator has failed over the node, and it has added it back, I believe. And we should see a rebalance get kicked off here soon. Oh, no. So it was down, so now it's going to be marked to be recovered. So you'll see that there will be a recovery type that'll pop up here any second. And then a rebalance will kick off, and this will bring your cluster back up to a healthy state. Yeah. So I think those are some of the more kind of basic, just general features. There are two other things, though, that I want to touch on. And one is, people today, when they're deploying clusters, they deploy their clusters to make sure that if there are even larger failures than just a node going down, that their clusters are still up and running. And so the two ways that you do this is you deploy across availability zones. You have rack zone awareness, and you make sure that that each node is striped across those zones. And then you also have disaster recovery, where you replicate your data to a completely separate data center. So one of the things that we did with the operator is we wanted to make it really easy for you to to or to write a configuration and just have all the management of making sure things went to the proper availability zones automated. And so what we did was we allowed you to specify server groups. And in this case, this server that I'm going to show is running in Amazon. And so they have availability zone groups like US East 1A, US East 1B, and so forth. And so if you want to stripe your servers across availability zones, all you need to do is add into your server configuration what availability zones that it needs to be striped across. And the operator will automatically take care of ensuring that your servers are equally striped across that group. So in this case, we specified 2 different server groups to be striped across. And so obviously you're going to see 2 in one group and 2 in the other. But it should be noted, if we scaled this cluster up or down, it would either add or remove based on what based on what availability zone the next server needed to go into. And so just in the interest of time, I uploaded this configuration already into a cluster on AWS. And I think I need to do port forward here. Okay. Okay, and so if I come to the server section here, what you'll see is when this cluster gets deployed, it's automatically deployed across all these server groups. And we allow you to have all kinds of different strategies for how you want to do this. You can either define it at a really high level in the configuration, and then any of your server groups will inherit that. You can have custom security groups to stripe across for individual server groups, or you could just say, I want all the servers in one group to be in one particular group. So you have various options for being able to do this, but this makes it really nice because you no longer need to think about exactly where you're putting your nodes. You just need to make sure that your Kubernetes cluster stretches across availability zones. The last feature that I want to show is cross-data center replication. So we did a bunch of work here, and unfortunately I ran into some networking issues, so I'm not actually going to be able to make the XTCR connection, but I can talk a little bit about how it works and show why it works. So if you look at this cluster, it has 3 different nodes. And if I look at our configuration, so actually, let me step back a little bit. So one of the problems with doing XTCR in Kubernetes is that there's internal IP addresses that are assigned to all the pods in Kubernetes, and then there's external IP addresses. And things outside of Kubernetes can't see inside of Kubernetes. And so the way that you handle that is by creating node port services. And these will open up a port on a specific IP address on that node so that the traffic can get forwarded from outside in. And so if you want to run cross-data center replication in a simple use case, you have to have a service for every single node in your cluster with the correct ports open. And so what we did in the operator is we wanted to make this easy for people, especially when adding and removing nodes, you don't want to have to remember to do this. And so we added an option called expose features. And so this means I want to expose a service on each node so that XTCR can work if I need it to work. And what happens when you do that is, if we come over here, you'll see we've created services for each node in the cluster. And as you add and remove nodes, these services will get added and deleted. And each service, we make sure that we have the appropriate ports open in order to properly run an XTCR connection. So we open the administration port, we open the data ports, we open the TLS secure ports and the indexing ports. And so this allows us to very easily allow you to XTCR data from anywhere outside of Kubernetes into a Kubernetes cluster in your environment. And I think that concludes the main features that I want to show in the demo. How much time do we have?
Well, but you've got 3 minutes yet before we go to Q&A. So.
Oh, okay.
All right, so we can go to Q&A now?
Yeah.
Perfect. Well, thank you very much. I think that's awesome. I mean, being able to set that up is just fantastic. All right, I do want to open it up. We've got about 12 minutes now for Q&A. So there's the first hand. I'll jump over there.
Along the same lines as the XDCR, does Sync Gateway work, and are there any specific considerations that you need to make for that to work if you're running Couchbase in this environment?
Yes. So in Couchbase 5.5, we made a change in the way that we handle the IP addresses associated with the particular node. So obviously, you need to know about the external IP address and the internal. And so we have support to do that in the server. As of today, XDCR is the only team that I believe has implemented that in a production sense. Our SDKs are working on it and are close to completion, and other teams are looking at that too. So if something's not available, it should just be a matter of time.
Yeah, I saw that you have put a password for admin, and it's static password.
Yeah.
So is there any way you can do a random password? Because I hate to create my all ports with same password and give to application.
Yes. So I skipped over the part about the password. So let me come back into the configuration here. OK. So there's this auth secret here. And this points to a Kubernetes secret by name. And so if I come into the cluster here and look at the secrets, you'll see there is a CB example auth. And if you unencode it, it's the username and password. So whatever you want your username and password to be, you should put it in a secret, and then you should reference that secret from your configuration.
Hi, I have a couple of questions. One is, in your configuration file, do we have to predefine the number of nodes, data nodes, and those sort of things? What if I have very demanding variable load coming during holiday seasons and others? How do I design that? Second one is, from an application point of view, when you bring up and down the nodes, what is the impact on the connectivity? Is there an automatic retry? Could you elaborate?
Yeah. OK, so for bringing up the nodes, yes. So there is an automatic retry. So when we first bring up the pod, obviously there's just no way that we can connect to it that quickly. And so I believe we have a timeout of 5 minutes to say if it's not there in 5 minutes, something's probably gone wrong. And so once the pod comes up, we kind of stay in this loop where we're waiting until it comes up and is healthy before we try to move on. So it's not the case where we bring it up and then we try to start doing other things and hope that eventually it's going to work. Yeah.
Regarding my first question, if I got a huge need for bringing up 40 to 60 servers, 60 nodes, do you think I need to predefine in a very waterfall way my configuration, or is there a way to do it in a more elastic way? Based on the load, it will create additional pods and load your custom images and all the stuff.
Yeah. So we don't have auto scaling. So basically, you couldn't just not even think about it and then all of a sudden come in one day and go, oh, great, now there's 40 new nodes and it's handling it. So we don't have that ability yet. But what you could do is, whatever, on November 14th, before you think that your sales are going to go crazy, you can just go in there and increase the size of the nodes from 10 to 40. And then the operator will automatically create all those nodes, cluster them together, and get you to a healthy state. So there's a small manual step, but it still should be fairly simple.
What are the main advantages of using Kubernetes versus Hypervisor with the VMs kind of configuration?
Yeah. So I'd say it's kind of dependent on what you want to do. In general, the big things that you hear are containers they take up less resources because you don't have to run the underlying operating system. So you can pack more of them together and more efficiently use your hardware. Containers in places where they're not quite used correctly can be less secure. Whereas if you're running on a VM, you're guaranteed more security because you have that operating system. I think those are some of the main ones that I hear. Do you know some of the others?
Again, with as I said in the beginning about you're thinking about moving from monolithic architecture to microservice architecture, the only way we can see that happening is through containerization, right? Because you want to move into the microservice architecture where your services are running on the individual containers. And that's kind of what is giving a lot of boost to the containerization.
Yeah. The other one I've heard, I don't know how much this affects people, but startup time is another one. So containers come up very quickly, whereas VMs, you have to load the whole operating system, could take a minute.
Other questions?
So I had a question about, do you get events like you said, 5 nodes are available, right? Mm-hmm. If one goes down, then Kubernetes is going to go and make it up. But what about like CPU? What if it just spikes up to 90 plus? Does it give manual alerts or anything?
Yeah, so the other thing that I didn't do in this demo, mainly because I ran on Minikube, is I didn't talk about resource requirements. So whenever you're going to run Couchbase, you're probably going to want to set these. If you have any experience putting together pods or a lot of other specs, you've probably seen these things before. And let me see if I can show a quick example here. Okay, so this configuration I'm going to show you is meant just for educational purposes. It probably wouldn't work if you loaded it in. But you can see here in the pods portion, we allow you to define all these different types of hardware restrictions and requirements. We also recommend that if you're running a database, you should probably only be running the database on that particular node. Probably not worth trying to pack other things on there because it could cause issues.
Other questions? Wow, tremendous, guys. Again, I really do appreciate, thank you for all your time today. Thank you, what a great audience, especially standing room only. Tell your friends and neighbors how wonderful the autonomous operator really is. Thank you.